cameras. The camera is one of the most essential components in Unity. The camera takes the contents of our scene and displays it to our users. Every scene must have at least one camera to render our scene objects, otherwise we have nothing to show. When a new scene is created, one game object is always included. This is the main camera. The game view camera is a component attached to a game object. This means we can manipulate or move our camera like any other game object, including parenting, scripting, or physical interaction. To create a first or third-person camera, including side-scrollers, we can use the player object as the parent. For first-person cameras, make sure the camera is at the character's eye height, looking forward from the character's point of view. For a third-person view, make sure the camera is above and behind the character. For a simple puzzle game or top-down shooter, the camera would be static, simply looking at and rendering the game. In this example, we are going to center the camera, remove any unwanted rotation, point it straight down, and lift it above the game board to simulate a top-down game. In this case, we are using the orthographic mode on the camera, which we will cover later in this lesson. We can have any number of cameras in our scene, each rendering different parts of the environment. In this example, we have 3 cameras, one rendering all of the dynamic objects in the scene, another rendering the static background, and a third rendering a UI overlay. All 3 cameras can be brought together to make a single presentation to our user. We will talk about how to properly use all 3 cameras at once later on in this lesson. When a camera is selected in the hierarchy, we see a preview of the camera in the scene view. When we have multiple cameras in the scene, this helps us to see what the camera is rendering. This preview is also helpful when we are in full screen mode to see what the camera is rendering, even if it's the only camera in the scene. Cameras will render everything that's in front of them and within their view. How much of the scene is within their view is shown in the scene view as a white outline. This shape is a view frustum. A view frustum is a pyramid or cone with a top cut off. The cut off top of the pyramid is the near clipping plane, and the base is the far clipping plane. The near and far clipping planes control the draw distance from the camera. Objects must be between the near and far clipping planes to be rendered. The sides indicate how much the camera can see side to side and top to bottom, and any part of the scene that is within the frustum will be rendered. Cameras have 2 different ways of looking at the scene: perspective mode and orthographic mode. These dramatically affect the shape and size of the frustum and the look of the scene through the camera. In perspective mode, the camera will render the scene like a real-world camera with a sense of diminishing perspective. We can see this in the scene view as the white representation of the camera's frustum gets larger as it extends away from the camera. This is the most common camera mode to use when creating a game. In orthographic mode, there is no diminishing perspective. All objects are rendered using a form of parallel projection from the camera. We can see this in the scene view as the frustum is straight and the front and back are the same size. This mode is usually seen in isometric games, like some real-time strategy or board games, or for 2D games, simple puzzle games, and when using an additional camera for rendering UI elements on top of the game view, like minimaps or heads-up displays. To control what is being rendered in our scenes, adjust the near and far clipping planes and the size or shape of the frustum. Field of view controls how wide the view of the camera will be. This is very much like using the zoom on a real-world camera. When the camera is in orthographic mode, size replaces the field of view property. This controls the size of the orthographic viewport. This is similar to field of view, but the value of the size property changes the size of both the front and back planes at the same time, as there is no perspective with an orthographic camera. Our scenes must have some sort of a background. This is controlled by the clear flags and background properties. The color value set in the background property will be what's drawn behind any of the objects in our scene if no other settings have been changed. This is the default blue color we see in a new empty scene. Clear flags determines what the background will be for a camera. This setting is particularly important when using multiple cameras. Each camera stores color and depth information when it renders its view. The portions of the screen that are not drawn upon are considered empty. The clear flags property will determine what is shown in this empty space. If we have a skybox set in our render settings, the background will be a skybox. Skybox is the default clear flag for any camera. A skybox is a material that contains several images that surrounds the entire scene, providing a textured background for that scene. For more information on skyboxes and render settings, see the appropriate lessons. If we don't have a skybox set or we choose solid color as our clear flag, the color value from the background property will be used behind any of our objects in the scene. Depth only is primarily used for multiple cameras. We will cover depth only in a moment. Don't clear will result in each frame being drawn over the last, creating a smear effect. This setting isn't typically used in games. When using multiple cameras, the most practical setting for clear flags is depth only. With this setting, each camera is given a value in depth, and the contents of each camera's view are layered on top of each other in depth order, starting with lowest depth first. Normally, the main camera is assigned the lowest depth value and has its clear flag set to either skybox or solid color. All of the other cameras have their clear flag set to depth only. This way there is one ultimate background and the images of all the other cameras are layered on top of the main camera. The content of what the camera is rendering is limited by the culling mask property. The culling mask dropdown will list all the layers available in the scene. The camera will render only those objects on the layers selected in its culling mask. For more information on layers and how to use them, see the appropriate lesson. In the case of the UI overlay, we have the UI element set to the UI layer. Our UI camera has its culling mask set to render only the objects on the UI layer. We have our clear flag set to depth only, and the depth set to the highest value of all the cameras in the scene. This way, the UI camera only draws the UI element based on the culling mask setting, and the UI element draws on top of all of the other layers based on the depth. It is also worth noting that the camera is set to orthographic to remove any possible perspective on the UI element. Typical uses of multiple cameras are to render UI elements like minimaps or heads-up displays over the world view, make rear-view mirrors and missile cams, or to force the drawing order of objects in the scene, like making sure that a gun in a first-person shooter doesn't get drawn inside the level geometry. The normalized viewport rect, render path, target texture, and HDR properties are more advanced and will be covered in another lesson.